I hope that you can able to see my screen. I hope that you're all have been enrolled in our GCR, and I have uploaded our teaching plan, syllabus, and all these things. Hope you have checked it. And for your first internal, you have portion till this ninth lecture plan. Okay, classification. So this is content beyond. We'll see that. Otherwise, we have discussed all this concept. Um, uh, till 7 and 9. Okay, so this is content beyond. We will see this data reduction at the last if time permits. Otherwise, our portions are like 1 to 7 and 8th one. Okay, and 1 to 7 and 9th one till this. Okay, till 9th lecture plan is for your first internal. So in the previous classes, we were discussing about all these things, machine learning, testing, training, predictive, descriptive task, and we learn about different machine learning models, geometric model, logistic model, probabilistic model. And in the previous class, we were discussing about features and different way of creating, constructing, selecting features. And for that, we saw so many mathematical model as well. So in this class, we are going to see about this classification, specifically binary classification and its performance evaluation. Okay, so let's start. We all know what is classification is. So we want to classify whether it is a ham mail or a spam mail. It is whether this person have this particular disease or not, and can be offered loan to this particular person or not. So whenever we have two possible answers, two possible output classes, we can say that is binary classification. Okay, so here we can say the output can be a true value or a negative, false value, or positive value or a negative value, and we could able to represent it in this way. And so the examples are like a medical test, whether we can say whether a particular person have this particular disease or not, and all these things. Right. The next one, we know, for example, when we have, we know machine learning means we are going to make a machine to learn from the data. That's what we are learning from the beginning. So when we want make a machine to learn from the data, so we will be giving lot of already available existing data to the machine, and by applying some algorithm, we will make the machine to tune to the already existing data, and by which we will be obtaining a model. And then when we apply a new, when we give a new sort of input to the model, we'll be trying to see how it could able to predict the answer for the newly given input to the particular model. So we know that if you see here, this is a data set which contains some data features like name, age, income, and then we want to see whether we could able to provide loan to this particular person or not. So we'll be applying some classification algorithm, and using the classification algorithm, we'll be generating some model. Here the model can be some classification rules are here. We are checking that if the person is person's age is youth and his income is high, then we can able to give safe to give loan to him. And here again, if the person's age is middle age and its income is high, then safe to give loan. And if the person's age is middle age and his income is low, then it is risky to give loan to the particular person. Likewise, we have lot of input data available here in the training data, by which when we apply some algorithms, it could able to frame some model by specifying so many classification rules. So next time when we apply some test data to this particular model, here we have some classification rules, then we have to say whether this model could able to perform well for this new testing data as well. By which we could able to check the accuracy of that particular model. And to evaluate this classification model, we will be using so many technique. One among that is confusion matrix. Okay, so we can easily develop a model, but if you're not evaluating the performance of a model, we cannot determine that the particular model is performing well and we cannot use it. So it is very important that we have to evaluate and we have to check, test how our model is performing. So to evaluate this model, its performance, one way of doing that is confusion matrix. Another word to say this is contingency table. So using this concept of confusion matrix, we could able to evaluate the performance of this model. Until now, you might have heard about so many other way of evaluating the performance. One generally used performance metrics is accuracy. But in every cases, this accuracy will not also perform well. For example, if we have a data set which is a not balanced one, then in that case, using accuracy as only the parameter to measure the performance will not work well. Because, say for example, what is this imbalanced data set means? For example, I have data set of 100% data set which says, so we'll take the same example here. Okay. So here I have a data set which says whether I can give a loan to a particular person or not. And you consider here I'm going to have only 20% details of risky data, and remaining all 80% of data is all about safe data. Then it is an unbalanced data set. Okay. So if I want to have a well balanced data set, means 50-50 it should be there. 50 samples of a person who I can able to give loan, and 50% of the data whom I should not give loan. So likewise, equally I have the distribution of the data set. Then I can say that data is a balanced one. At least I can have like 60-40 or 45-55. At least something around this, then I can say, okay, almost I can trust it. But if I have a very, if it is 10/90, 80/20, then it could not, that data set could not make a better model. It may lead to wrong decision or wrong output, because even though you use this accuracy as a performance metrics, and if you evaluate it, even though it is giving you 90% accuracy or 95% accuracy, but still it will not perform well. Since the data set is an imbalanced one. So in all those cases, in this kind of way, if you go for performance matrix, performance evaluation with the help of confusion matrix, it will be almost we could able to evaluate it in a proper manner. So confusion matrix is a table, so where we could able to describe the performance of a classification model like this. So here we have rows and columns. Generally, the values of the confusion matrix are like, if we consider here, I have considered the rows as actual value and columns as predicted value, and the values or the representations of this confusion matrix are true negative, true positive, false positive, and false negative. These are the representations used in this confusion matrix. Okay, so with actual data and the predicted data, and the value in this confusion matrix are true positive, true negative, false positive, and false negative. Let's see one by one all about it. So what does this true positive means? Consider we have I want to predict whether a person is pregnant or not. Okay, so what is true positive? Actually, the model is saying you are pregnant. Okay, that is a positive result, and that is true. So that is said to be a true positive. Hope you are getting. So here, these are the representation used in the confusion matrix, and the value present in the confusion matrix are true negative, false positive, false negative, and true positive. So we are going to see one by one. First is true positive. You can see like this. The model is saying positive and it is true. Here you can interpret like this. The model is saying positive, but it is false. And here you can say the model is saying negative, but it is false. And here the model is saying negative and it is true. Okay, so that's the concept. So here it's like the model is saying the person is pregnant. So it's a positive result and it is actually true. Okay, and then true negative. So what is true negative? The model is saying the person is not pregnant, which is a negative result, and it is true, right? Not pregnant. You consider pregnant as a positive result and not pregnant as a negative result. So the model is going to give not pregnant, which is a negative result, and it is true. So that is what true negative is. A person who is actually not pregnant, which is negative, and it is classified as not pregnant. Okay, so that is true negative. The result is negative, but it is true only. So that is what true negative is. And next one is false positive. What is this false positive means? The model is saying the answer is positive. Positive means what? Here in this case, positive means the person is pregnant, but actually it is false. So that is said to be as false positive, which means the model is giving the output as positive, but it is false. False means it is wrong. So that is said to be as false positive. So a person who is actually not pregnant, he is not pregnant. But the model is saying it is pregnant, which is positive, but it is false. And what is false negative? The model is saying the person is not pregnant. So it is a negative result. Not pregnant means it is a negative result. Actually, that is false, right? This person is not pregnant. It's a false result. So that is what calls as false negative. The model is giving a negative result and it is false. False means it's wrong again. So that is what is false negative. So these are the four parameters or four confusion matrix representation present in this table. Okay. So in some confusion matrix, actual value will be in the column and the predicted value will be in the rows, but both are okay only. But you have to see where it is represented. But here we are going to see the actual values are in the row and predicted value are in the column. And I hope you got what is true positive, true negative, false positive, and false negative. Let's see, discuss it more, little more. So this is our confusion matrix, and this is the values present in the confusion matrix. I hope that what it is, everything mean by. Okay, so confusion matrix is also called as contingency table, and which is going to describe you the performance of a classification model. We say that as a classifier. And when a new test data is given and we want to measure it. And so the number of correct and incorrect predictions are summarized with count values. So here in this table, we are going to take the number of correctly predicted value and incorrectly predicted value are counted and it is represented. And so it contains both actual value as well as the predicted value. So here the rows are represented by actual values and the columns are represented by the negative predicted value. Okay. So here is again an example, same thing, confusion matrix. The rows are representing the actual value, columns are representing the predicted value. So true positive in the sense what I said, positive results, but it is true. Okay, so it is saying that for predicting whether the mail is a ham mail or a spam mail. So that is what we want to do, want to classify. So in that case, the given class is a spam. Okay, which is here we are going to consider spam as a positive result and ham non-spam as a negative result. So here the given class is going to be spam and the classifier have correctly said it is a spam. So that is true positive. What is false negative? It is going to give the negative result, but it is false. So which means what? Given the class is spam, however, the classifier has been incorrectly predicted as non-spam. Okay, so it is going to give the negative result, which means not spam. That is negative, but actually it is a false one. And what is false? Positive. Positive means here the model is going to give the output as a spam, which is a positive result, but actually it is a non-spam. So it is a false positive output. And what is true negative? The model is going to give you your negative result, but actually that is a true data. Okay, so that negative one is correct, so that is called as true negative. So here let us say one example. You consider for an email classification we have 100 data set. Okay, 100 values in a data set, 100 samples are there in a data set. So out of which 65 are spam mail and 35 are non-spam mail. So after doing the classification of this email, the confusion matrix are represented with these values. Okay, so in the data set there are 100 samples, 65 of them are actually spam and 35 are actually non-spam. So how the model is performing is presented with the countable count. I said already it is evaluate and all these values are given some count, right? So here it is saying true positive is 45 and true false negative is 20. So 45 plus 20 is 65, which means I said rows are representing the actual value. Okay, rows are representing the actual value. So here in this case, this is the row. Okay, in this row actually represents the actual value, and this columns are representing the predicted value. So this two rows says the actual value. What is the actual value for a spam? There are 45 plus 20, that is 65 spam mail. Out of 65 spam mail, 45 are correctly classified as spam mail and 20 are incorrectly classified as non-spam mail. So that is in actual. And in non-spam mail, you can see 5 plus 30. That is 35. Totally 35 non-spam mail. That is the total actual value, out of which 30 are correctly classified as non-spam mail and 5 are incorrectly classified as spam mail. Actually it is a not spam mail, but 5 are classified as 30 are correctly classified as non-spam mail, 5 are incorrectly classified as spam mail. Okay, so this is what we can interpret from this. And when you take this column wise, okay, so which is the predicted value, so the column represents the prediction, this row represents the actual value. Okay, so when you see here 45 are correctly classified as spam and 5 are wrongly classified as non-spam mail. Okay, and in this 30 are correctly classified as non-spam mail and 20 are wrongly classified as spam mail. Okay, so this is, so I hope you got some thing how you could be able to interpret from this confusion matrix, right? So I hope that you are all clear until this. Are you all clear until this? Are you all following me until this? Are you all following me until this, ma? Okay, thank you, ma. Thank you. Thank you, ma. Thank you that you are all listening. Good. God bless you, ma. So from this confusion matrix, we are going to measure now. We are going to come to some measurement. Okay, measurement, some values we are going to measure now from this table. So first one is said to be as sensitivity. You might have come across this sensitivity terms many places, right? So it is a very important, like accuracy. Generally, whenever we say any model, we will be measuring the accuracy of the model. But in all cases, accuracy alone cannot be trustable. We cannot, only by calculating the accuracy, I cannot say that my model is performing well. Okay, so that will not be a correct value when the data set is balanced or not balanced. So it is better idea to calculate this using this confusion matrix. In this confusion matrix, the first thing we could able to measure is sensitivity. So the sensitivity is also called as recall, or it also be called as true positive rate. Okay, sensitivity is also said to be as recall, or you can also say as true positive rate. So this place, okay, this row ways is said to be as recall. So this way is said to be as recall. So what does this recall says? This already we know that this place, no, this row is actually the actual value. So out of all positive, so here we are considering spam as positive, okay, spam mail as positive, and ham mail or non-spam mail as negative value. So here this row represents the actual value, okay, actual value, out of which, out of all positive classes, how much are predicted correctly. So that is said to be as recall. Okay, so out of this actual value, how much are correctly predicted, that is said to be as recall. So how will we write the formula? That is true positive, that is correctly classified, divided by the total number. So the total number means what? TP plus Fn. So that is the formula for recall. So out of all positive classes, which means spam we have considered as the positive class. So out of all positive classes, how much has been correctly predicted is said to be as what? Recall. So how will we calculate? We have to calculate, right? 45 divided by 45 plus 20. So what we are getting the result? 69.23. So that is the recall, or we can say the sensitivity. So what does it mean? Out of all the positive, out of all total positive classes, 69.23% is only predicted correctly. Okay, out of only 69.23, out of all this, only 69.23% is spam mails are correctly classified by excluding the non-spam. Here we are considering only the spam mails. Okay, here we are considering only spam mails. In the spam mails, 45 are correctly classified. Here we are not bringing in the non-spam mail. Okay, so in only the positive classes means here we know only 65 are the positive inputs given. Out of this 65, how much is correctly predicted? 45 is correctly predicted, right? So 45 divided by 65, we'll get 69.23. So 69.23 spam mails are correctly classified by not considering the ham mails. Okay, and the next one is specificity. Okay, this is the next measurement. So this sensitivity is said to be as true positive rate. Okay, true positive rate, and specificity is said to be as true negative rate. So how will you take the true negative rate? True negative rate is going to consider only the negative classes. So here, this one, non-spam mails. So this part alone, the actual value. So how does we write this one? The true negative value divided by the total, which means true negative divided by true negative plus false positive. So that will help you to get the specificity. Okay, so it measures the negative labels and how much is correctly predicted. So here if you want to calculate, so it is like 30 is Tn divided by 5 plus 30. So that will give you the specificity value. So it results by 85.71%. So from this, what will you say? Out of this 35 ham mails, only 30 are correctly classified. So we can say 85.71% of non-spam mails are accurately classified. And here also you should remember, we are not considering the spam mail. We are considering only the ham mails. Okay, ham mails means not spam mails. Out of not spam mails, 30 are correctly classified out of 35. Okay, so 30 divided by 35 is the thing, total. So here we have 85.71% of non-spam mail, which means the negative class are accurately classified. So that is said to be a specificity. Okay. And the next one, accuracy. Generally, this is the formula used for any performance evaluation. So how will we calculate the accuracy? This value, the diagonal value. So always when we calculate the accuracy, the actual values are this only, the diagonal values. This is the actual value. These are the wrong values, wrongly predicted one. So whenever you calculate the accuracy, you have to take true positive plus true negative divided by the all total value, right? True positive plus true negative plus false positive plus true negative, the total value. So this diagonal, true positive plus true negative divided by the total of all these things will help you to find the accuracy. So when you substitute it, we will know here the true positive is 45 plus true negative is 30 divided by true positive is 45, true negative is 30 plus 5 plus 30. That is false positive is 5 and false negative is 20. So when you calculate, we will get 75%. So what is the meaning of this? 75% of the examples are correctly classified. So it is not specifically saying ham mail or spam mail. Out of all this together, 75% of the data are correctly classified. So that's what this accuracy is mean by. And so generally you will be seeing whenever we go for confusion matrix, generally you can see these parameters like recall and precision. Usually you can see these two terminologies. So next important measurement we will be using is precision. So what does this precision says? So here it is going to evaluate this part alone. So we already learned the row value specifies here we are considering the row value as the actual value and the column value is the predicted value. So what does this precision specifies means? It specifies the total number of correctly classified positive examples and the total number of with the total number of predicted value. Actually this is the total predicted value, out of which how much is correctly predicted. So that is the value of this. Okay. So I will repeat what is precision means. Here earlier what we found is sensitivity, in the actual value, how much is correctly predicted. Actual value. Here in precision, out of total number of predicted value, how much is correctly predicted. That is precision. Okay. So to calculate this, the formula again is this correctly calculated value, TP divided by TP plus FP. So that will give you the precision. So here 45 divided by 45 plus 5, that is 90%, are classified as spam, are actually spam. Okay. So out of which from the total predicted value, 45 are correctly predicted because this column specifies the predicted value. Out of this total predicted spam value, which is 45 is correctly predicted. So that is what the precision is. Okay, so it is the ratio of total number of correctly classified positive examples with total number of predicted positive values. So here because this column specifies the positive value, which means the spam. Right, out of this positive classes, 45 is correctly classified and 5 is wrongly classified. So that is what the precision is. So generally you will be using this recall and the precision. Okay. So now recall already we have learned. Recall means true positive divided by true positive plus false negative, right? True positive plus false negative. Okay. So now using this precision and recall, we are going to calculate next parameter called F1 score. Generally, it is called as F1 score, which is an F measure. So to balance this actual value and the predicted value, we are going to combine we are going to use the combination of this precision and the recall. Okay, so which will give us the balance of, what is precision and what is recall. So precision we will be calculating from the predicted value, and the recall we will be calculating from the actual value. To balance this both, we are going to use this F1 score. So first we have to calculate this precision value and the recall. Once we calculate it, if you substitute all this, we will get F measure, or you can even say it as F1 score. 2 into recall into precision divided by recall plus precision will help you to measure the F1 score, which is the combination of precision and the recall. Okay, so totally accuracy, all these other performance evaluation formulas: accuracy, specificity, precision, and recall. So generally these both are very important. And the last, this values, this marginal, this value, the last column values are said to be as marginal values. Okay, so these are marginal values. These are marginal values, which says the total of all this. 20 plus 30 is 50, 20 plus 30 is 50, 40 plus 60 is 100. So in what way you calculate, we'll get the total value of all these things. So this is said to be as marginal. Okay, if you see in any of the output, I hope that I gave you some assignments already. You would have come across all these parameters, output evaluation parameters already. I will check it later. Okay, so I hope that you are all clear until this. What is confusion matrix, why we want to move from accuracy to confusion matrix we saw, and in the confusion matrix we learned about different terminologies like true positive, true negative, false positive, and false negative. Using this value we calculated all this performance evaluation metrics like sensitivity and specificity and precision, finally accuracy. Then using these values, the next way to represent the performance evaluation method is ROC and AUC. Okay. So you might have seen this ROC and AUC somewhere. So that is said to be as the coverage plot, which will help you to visualize this results. What we have seen here is false positive and the true positive values. Okay, so let's see one by one the coverage plot. First one is ROC, okay, which means receiver operating characteristics, which is shortly said as ROC. So to calculate this ROC, we will be using true positive rate and false positive rate. Okay, so these are the two parameters. So we know what is true positive, false positive, all these things. So to calculate this ROC, the important two parameters we are going to use here is true positive rate and the false positive rate. Okay, and so this two, so here you can see here in this graph, true positive is in the y-axis and the false positive is denoted in the x-axis. And how will we get this graph is actually what we have to do is the important thing, the important parameter we are going to consider here is the threshold. Okay, so we have to select different threshold value, and for the different threshold value we have to find the true positive and the false positive rate, and that value to be plotted here, and we have to join all this curve. Generally if the model is perfect, we will be getting this value, right? So which is, the value will be ranging from 0 to 1. Okay, and here again 0 to 1. So which means if you get 1 comma 1, which means the model is perfectly okay. And so this is the perfect model, and here 0 comma 0, right? And after that we have to set different threshold value. You can set threshold value as 0.5 here you can set, and you can set another threshold value. You can set another threshold value. You can change the threshold value as 0.2. You can set the threshold value as 0.3. So likewise, by using different threshold value, you have to calculate this true positive and false positive value by keeping it in the confusion matrix using that true positive rate. You know what is true positive rate? How to calculate the true positive rate? This is the formula to calculate the true positive rate, which means also called as recall, right? So then for example, how will I make you to understand? So we know what is true positive rate, the formula Tp divided by Tp plus Fn. Say for example, you consider say for example, you consider that I have some data set. Okay, I have some data set. Here I have so many data points which may be representing ham mail and spam mail. Okay, so you consider this might be a ham mail and this can be a spam mail. Okay, this can be one way of representing. Another way of representing this is say for example, I will show you another one which you could able to easily understand. You consider there is a graph and here it is going to say about the weight, and here by seeing that we are going to see whether the person is obese or not. So when the weight increases, generally we say the person is obese, okay, or we can say anything. So here we have some data for it, some data point regarding this. Okay, so we can see if this person's weight is this, and first we have to draw a linear value, and then we have to say if the person is weight is this, and we have to say whether the person is obese or not. For that, what I am going to do is, initially I am going to have the threshold value as 0.5. And say for example, you consider this is the threshold 0.5. So if the person's weight is this, and I'm going to consider this as the value, and this person is not obese. Okay, so the value who are coming below this I will consider as not obese, and the value which is going above this threshold value I'll consider as obese. So by this 0.5, this value, we have to plot this confusion matrix. Okay, so for each and every value, we have to say how much, for example, there is 50%. Out of 50%, how much this is if actual value, if this is the actual value, out of 50%, you consider 20% are obese and 30 are not obese. So here we have to say obese and here not obese. So actually this is obese value and this is not obese value. So we have to, by seeing all this each and every value, you have to say out of this 20, 15 are correct and 5 are wrongly predicted by using this threshold value. And then same with the not obese. Out of 30, you can say out of 30, I can say like 20 are correctly predicted and 10 are wrongly predicted using this threshold value. So I got a confusion matrix, right? So using this confusion matrix, we have to calculate the TPR. What is TPR? True positive rate. True positive rate is also called as recall. For recall, we have a formula. What is the formula? True positive divided by true positive plus false negative. So this formula will help us to give the true positive rate. Same way we have to calculate the false positive rate. Then this false true positive rate and the false positive rate, we have to plot it. Right? Similarly, we have to set the next threshold value. Say for example, I'm going to make this as the threshold value 0.7. then I have to calculate all the whether the person is obese or not. So whichever value which is coming below this 0.75, all I will consider as obese. Okay, not obese. And here the value which are going beyond the 0.7, I will consider as obese. So in that I will get another confusion matrix. Using that confusion matrix, I will again get a TPR value and a FPR value that I will plot. Okay, and then again you can even keep the what this threshold point here also. 0.3 as the threshold value. So whichever value coming below this 0.3, I will say as not obese, and whichever value going beyond this threshold value, I will say as obese. Right? By that we have to plot this true positive value and true negative, false positive, everything. Then calculate the TPR and FPR, and then again using that we have to plot it. So by changing different threshold value, we have to calculate the TPR value and FPR value, and we have to draw a logical regression curve like this, regression curve. Okay. So that value is said to be as ROC curve, receiver operating characteristic. I hope now you can able to understand this. So AUC and the area which is coming below this is called as area under curve. So this is the ROC curve, receiver operating characteristic value. And the area which is coming beyond below this are all said to be as, if the curve is coming here, if you use another set of values and if you get a curve like this, and so the area of under curve, the curve will be this. For this, the area under curve is this, all this full area. Okay, so this is area under curve and this is ROC. Okay, receiver operating characteristics. So from this, I think if you read it now, you will understand AUC ROC curve is a performance measurement for classifying problem at various threshold level, right? So we have to use different threshold setting, and then you have to measure the performance. So it can also be thought of a plot of power as a function, and we could able to evaluate the errors as well. So okay, and we could able to separately measure the ROC and AUC separately, and we could able to distinguish which is the higher AUC, how you are getting the different values. Okay, so I hope you got some idea about what is ROC and AUC. Do you understand what is ROC actually, how to form a ROC? Do you understand? How many of you understand ROC? Are you getting? Yes, thank you, ma'am. I will see in some more example about this in the next class. Okay, so how this ROC and AUC is useful in measuring the performance. But I hope that you got some general idea about how to frame this ROC curve, right? So the remaining we'll see in the next class. Thank you for listening, ma. So I'll quickly